Welcome, if you've just joined us or you've been before, to the DevSecOps track here at OWASP AppSecEU 2020. For those new here, my name's Nathan Britton. I'm an OWASP volunteer, an OWASP chapter leader in the Birmingham, in the West Midlands in the UK. And I'll be the moderator for today's session. And we're going to be talking all about operationalizing threat modeling. So about 45 minutes, we'll have Fraser Scott, who needs practically no introduction. He's been eulogizing and talking about threat modeling for years. Sorry, Fraser, I don't want to give any ages away, but been doing it for absolutely ages. And he's going to be delivering his talk, Evolving Threat Modeling through the Open Threat Model format. As with all the other talks today, you can submit your questions that we'll get to in the final 10 minutes or so to Fraser in your Hoover app or in the browser of the Hoover. Just go to the Q&A section and I'll keep an eye on them as we go along, and I'll fire them over to Fraser as we go. But yeah, that's more than enough from me. I'm sure you all want to get to hear all about threat modeling and the open threat model format. So Fraser, I'll hand the reins over to yourself.
Thank you very much, Nathan. I will share my screen. Right, so hi everyone. Welcome to Evolving Threat Modeling through the Open Threat Model format. So a little introduction to myself. I'm Fraser Scott. I'm the VP of Product at Erious Risk. I've been involved in threat modeling for about sort of 7 years now, I think it is. Initially in the open source space, I created a sort of threat modeling as code project called ThreatSpec, and then for 3 or so years, threat modeling in financial services space. My general background is cloud security, DevOps. I'm a sort of recovering sysadmin and all that kind of stuff. And you can see a range of places I've worked for previously. So I'm going to be talking about threat modeling, but this is going to start off with a little bit of a history. Once upon a time, information technology was nice and simple, and hopefully most people will recognize this office from the IT crowd. Back in the day, so early 2000s and beyond, and before that, information technology was, a bunch of servers and some switches and some firewalls and things like that. And that was kind of the extent of what we had to really deal with. And obviously we had mainframes and a few other things kicking around and voice systems and all that jazz, but things were relatively straightforward back then. But things were also quite a lot of work. So I used to work for an internet service provider when I started my career, and we used to look after the infrastructure and the systems and the network infrastructure and all that kind of stuff for our customers and for ourselves. And that involved a lot of manual configuration, a lot of manual building of Linux boxes and FreeBSD and Solaris and all that kind of stuff. That was some of the Cisco stuff obviously used configuration files, which was pretty cool, but a lot of the systems had to be built and maintained. And the way you did do automation, you were typically writing custom bash scripts, and you were we used to use Perl. So our entire infrastructure was held together by horrendous Perl one-liners running in cron jobs, for example. We did a pretty awesome job of applying sort of clever practices. So our DNS infrastructure was maintained through CVS, so not even Subversion at the time, right? CVS, and then we used M4 scripts to sort of add some templating and things like that around the DNS zones, and that was pretty bleeding edge at the time. But then in the background, things were starting to change. And over the years, from 2001, we saw the proper introduction of virtualization. Obviously, there'd been things, and emulation had been around for a while, and virtualization was starting to find its way into the CPUs, and we saw the creation of VMware, ESX and GSX. And at the time, actually, we started leveraging that within the internet service provider I worked at, sort of in 2006 or so. But this was really the beginning of a big transformation that was going to hit technology over the following 10 years. 2005, Puppet came out, and that was really the first step away from every single organization out there having to maintain infrastructure and writing custom bash and Perl scripts and other things. This was really the first time that there was a standard way that you could describe your infrastructure in a deployable, repeatable, and technology agnostic way. So you could, one person could write a public, what do they call them, manifest or whatever it was, and you could share that with others and you could learn from others. And then 2006, we started to see the first generation of AWS services. So at this point, we basically commoditized computing and storage in a way that was never really done before. 2009, Chef, very similar to Puppet. Chef was founded, slightly different approach, using pure Ruby as a DSL. But 2009 also saw two other key moments in the DevOps movement, as it turned out to become. There was the 10 deploys per day talk at Flickr, and Patrick Dubois organized the first DevOps day. And I think that's the first time that the term DevOps had been used. And then obviously over the next few years, other things changed and things continue to evolve a bit more rapidly. And at this stage, we're very much going from the birth of DevOps to DevOps becoming mainstream. And we've got Google announcing Kubernetes and Terraform being released in 2014. So this is giving us an interesting indication about what has happened in the technology space as a result of the natural kind of evolution of technology and how we manage and maintain technology. And what that gives us is some pretty awesome stuff. These days, we have literally thousands of cloud services that we can use, and they're ready to use out of the box. AWS has over 500, I think, 600 or so Azure services. If you look at the number of cookbooks that are available through Chef, it's in the thousands, 4,000, I think. There are 31,000 Galaxy collections for Ansible, et cetera, et cetera. Apparently, there's over 9 million Docker images available on Docker Hub and 174 official supported images. So what DevOps has created is this wealth of information that's available to us at our fingertips on how to build and use and leverage infrastructure and the fabric that you need to build the applications that your organizations are probably working on. And obviously, this is 2022. DevOps has been around for a while, so I'm probably going to sound like I'm preaching to the choir here, but it's not an understatement to say that DevOps has fundamentally changed how we think about and manage technology. So, where we had physical hardware before that took months to purchase and install, we have instant access to cloud infrastructure, which you literally pay for by the hour. What was manual build and configuration of systems and networks, we can now automate that throughout the stack. And again, what was once custom scripts and cron jobs holding everything together, we have literally countless templates and tools and configuration artifacts that can be shared and reused. So what this means fundamentally is that the common problems that we all face as organizations, like how to deploy a database, that's solved in a generalized way. I don't have to go and reinvent the wheel just to deploy a Postgres database, because there's only a few ways of really deploying Postgres in a sensible way. And because that's a repeatable thing, it's now been automated away thanks to things like configuration and RDS, Chef and Puppet and things like that. So what DevOps gives you then is repeatability and consistency. Those two themselves are very important, but that also creates the foundation for things like testability. If I can repeatably build and configure my infrastructure, I can do that in a way that I can check now whether I do have the repeatability and consistency. So I can start writing tests to ensure that my infrastructure and my services, etc., are behaving correctly. And because I now have testability, because I know and I can have confidence in that repeatability and consistency, I can suddenly do this at scale. So I don't have to run around building stuff by hand. I can feel confident that I can apply, whether I'm building 1 or 1,000 databases, I can do that with confidence and at scale. And then that gives us collaboration. So the more problems that we can solve, the more that we can make available to others to, where we have solved that problem for somebody else, we can make that and share that available, make it available to them. And that creates persistent learning. So whereas before, maybe, a Confluence page or whatever had some other wiki had instructions for how to go and build a particular piece of infrastructure, you had to then go and manually follow, hopefully not screw things up on the way. now these artifacts, these CloudFormation templates, Terraform files, Chef and Puppet, that all represents persisted learning. So that's stuff that we've solved. We know how to do this, and anyone can access that. Anyone can read and learn from that, and maybe even evolve and adapt from there. And that results in things like good practices and best practices. This is really the best way to build a server. This is really the best way to build a database or whatever, or a network. And you can encapsulate those in these kind of artifacts as good and best practices. And what that means is that frees you up to focus on the unique context and the problem space that your organization faces. So by not having to worry and deal with having to build all these random bits of infrastructure that everyone already knows how to do, you can focus on what matters to your organization. So there's a hypothesis then. The evolution that's happened for DevOps is currently happening in, well, for security, in what we would typically refer to as DevSecOps in this track, for example. And that would suggest that whether we like it or not, that evolution happens because of the nature of changes in technology and the nature of market forces and things like that. So threat modeling, and this is the hypothesis then, will inevitably need to evolve because the context in which threat modeling exists will continue to evolve. So threat modeling is not something that sits outside and is just its own little island. Threat modeling is fundamentally a process of development or operations, but from a security design perspective. So what can we imagine is going to happen for threat modeling in the same way we saw happen for DevOps and then now DevSecOps? So that's the hypothesis. And what we're going to do in this talk is we're going to look in a bit more detail about what happens when you're building an application, and we're going to use Wardley maps to draw those up and try to get to understand, trying to get a better understanding of where cloud and CI/CD and sort of pipelines and things like that, how that all plays together, and then we'll look at the implications for threat modeling. So before I get started, if you saw my talk last year at OWASP AppSecEU, I talked a little bit about Wardley mapping. I'll spend a couple of minutes talking about it now for those who've not come across it, because it's a very, very powerful framework for thinking about, particularly about evolution of technology. At the top, we have an anchor, and what this is the perspective of which we're looking at this map. So this is typically something like a user or a customer or something from which we are we're going to draw a map, but we're drawing the map from the perspective of that user or that customer or whatever. On the y-axis, we've got visibility. So things at the top are more visible to that anchor, to that user, and things at the bottom are less visible to that anchor. So it's either less physically visible to them, or just maybe not as interesting or not as obvious to them, where the lower they are on the y-axis. And then the x-axis is the stages of evolution. On the left, you've got Genesis. So things are very novel, things are very new, poorly understood. There's a lot of uncertainty. Things are constantly changing, and we don't really know what's going on because it's so new. Then over time, things evolve and they become custom. So you start to see emerging practices. You're now in a process of not complete uncertainty, but rapid learning. And you're starting to do things, you're starting to try things a bit more actively and put things into practice. And from a market point of view, this is where we start to see forming markets. Things evolve further to the right, and you start to deal with product. So this point, we have good practices. There may be competing ways of doing something. Two different products may try to solve the same problem in two different ways, and that's cool, that's fine. But they might have different strengths, but we still have reached a relatively stable stage at that point. And this is where you start to see rapid growth in adoption, for example. And as I said, you've got this sort of stabilization happening. And whereas before a market may have been forming, at this point it's now growing. And then on all the way on the right, we have commodity. So this is where we're dealing with best practices, this wide, ubiquitous, widespread adoption. It's almost the sort of the cost of doing business. It's just taken for granted at this point, and you don't really have to think about it. It's just the way it is. And so typically you would expect things to be slower to change here, because if it's ubiquitous and sort of the cost of doing business, you can't really deal with constant change in that environment. And this is where you have mature markets. So a good example of something that's obviously a commodity is electricity. We don't really have to think about it. I don't wake up in the morning and worry whether I've got electricity or not because of where I live in Europe. It's just taken for granted. I pay for it by the ridiculous amounts per second these days, it seems. But it's just on demand, on tap. But I also wouldn't want the voltage to suddenly change overnight, or for the plugs to suddenly change overnight. So I have a lot of stuff that relies on electricity, so I need that kind of stability there. So what we're going to do is we're going to draw the process of building a greenfield application from a developer's perspective. We're going to lay it out on this Wardley map, and then, as I said, we're going to look at it from what does this imply for the evolution of threat modeling. So, developer, I've got a idea or a problem to solve, and I want to build some sort of product or service to do this. So the first thing I'm probably going to do, which is number one, is, I don't know if you can hear that, but some things just flown right over the house. First thing I'm probably going to do is a bit of research into the problem space. I'm going to look at what's currently out there. Maybe I have some internal documentation related to this problem or this opportunity. Maybe there are published articles or research that I can refer to. So this research is probably going to be very unique to what I'm doing, and it's going to be subject to rapid change. So it really sits in that genesis. And as a developer, it's right at the top of what I'm doing at the moment. So it's very high up on that visibility. After the research, I've come up with some possible ways to solve this. I can start to plan and think about requirements and user stories and things like that. So the research has dropped down, it's less visible, but we're still in this this Genesis space. So again, we're expecting things to change very rapidly here. We have a lot of uncertainty here. We have a lot of change going on and a lot of uncertainty still, but we're starting to try to put a bit of a handle on things by breaking things into user stories and sort of bucketing it and slicing things. Then based on those user stories or those requirements, whatever, I might want to go and develop a prototype. So not necessarily something that actually works, but something I can put in front of a customer or a set of users and says, and so I can test, is this the kind of solution that would work for you in solving whatever problem you're having? And that would be leveraging the user stories, but it may leverage other things out there that are more productized or commoditized, like prototyping software, classic being something like Figma. And there may be design practices that I should be applying that seems to be established within the particular domain that I'm in. And I may be wanting to apply those to my prototype as I'm designing that and validating that with customers. So fundamentally, what we've been doing at this stage is design. So we've done research, we've looked at how we could possibly solve this and split this up into different ways. And then we've decided, okay, we'll start with this and we'll build a prototype. And that's a sort of design process. We haven't written a line of code at this stage, but we've tried to get a handle on the problem. Now, this doesn't necessarily imply waterfall. The way I've been describing it, it sounds like maybe it's a drawn out process, maybe 3 months long, but that's not necessarily true. If you look at things like design sprints, this could happen in a 3-day process. You could start off with a research objective, do a bunch of brainstorming, and end up with a prototype within 3 or 4 days. So this can still be a very agile and very rapid, and it should be. This should not be a drawn out process. You should be trying to validate that prototype as quickly as possible. So, you should be applying good product management practices, etc. So at that point, we've got a prototype, we validated it. Now we're starting to build a minimal viable product. Not everyone likes that term, but you get the point. It's the most minimum set of functionality we can actually build to put in front of a customer in a sense that it actually works. And now we're talking about writing code. And this means things get a lot more complicated. So we are probably not going to be writing absolutely everything from scratch. We're going to be leveraging libraries and frameworks like React and all sorts of things. We're probably going to be using web services like Node.js or Tomcat or whatever. This has to run on something. This web service or whatever needs to run on some sort of infrastructure. Again, these days you wouldn't go and build a server for it. You would go and leverage cloud infrastructure or serverless or something like that. So you can see here that From a developer's point of view, you've got from the developer's point of view, you've got the MVP, that's the thing that's really in focus, but it has all these other pieces that it relies on. Some of those are much further to the right, of course, like cloud infrastructure, which is a commodity. We've also got testing. So slightly controversially, I put testing on the left here because when you're building an MVP, you probably don't want to be over-investing in the testing. You probably just want to be doing the very minimum sort of smoke testing that you can do to make sure it's kind of working, because again, we're in custom, you're going to see a lot of iteration here. So you don't want to be over iterating on having to rewrite all of your tests all the time because of all the constant change. And then we've got a CI/CD and the build templates and artifacts, like all those Chef and Puppet and AWS templates and all that kind of stuff that we saw earlier. And then finally, at this point, over a period of months or weeks or whatever it is, the MVP iterates after release after release after release into a mature product or services. We're still relying on the same sort of cloud infrastructure. We're still relying on CI/CD. The testing has moved to the right now, so we've probably got testing more embedded into the CI/CD pipelines. We may even block the build or block the deployment in some circumstances. We're leveraging more mature test frameworks and all that kind of stuff. And we've got this business logic. So while the product or services is sort of productized, I've separated out the business logic that is still very custom to us, and it may still sort of evolve within the context of that product or service. And that may result in needing new features on the left there in 6. So we go through the whole process again, but this time not as a greenfield application, but as a subset of that product or service in the form of new features. So as you'd imagine, this is probably quite a familiar position to be in. And this feels like the sort of the ripe ideal state for DevOps, right? So we have cloud, we have our CI/CD pipelines, we have automated tests. So everything from a DevOps point of view, and arguably from a DevSecOps point of view, is in this ideal state. So we can automate everything at this point, right? That's awesome. Everything's sort of huge chunks of stuff on the right. We can automate our cloud infrastructure. We can automate our CI/CD pipelines. Everything is automatable, which kind of takes you to the point of the natural conclusion of, cool, we don't really need people at this stage. This is the world of machines driving machines. But that's obviously not true, and I was being slightly facetious there, because if you think of this in terms of the Wardley map, the things on the right, at the bottom right, yes, that is in a ripe position to be automated. We've got pipelines, we've got cloud infrastructure, we have all these kind of templates and things like that. That is perfect for automation. But the stuff in the top left, in custom and Genesis, that is still highly visible, that really does still need humans to be involved. That the business logic is something really only that exists inside a developer's head until that developer has decided how to represent that as code. So, we don't hire developers to write code. They're not machines that take Jira stories and turn them into lines of code. We hire developers to solve problems, and they just happen to solve problems by writing code. So all of that business logic, all of that design work, all of that understanding the problem and creating new solutions is a very human-centered process. Once you've solved a problem in a general way, you can automate it, and it's not a problem. That's something that's a solved problem, and then we can build on top of that elevated automation and that elevated generalized solution at that point. This is because fundamentally software manufacturing happens in the CPU and everything else is design. If you saw my last talk last year, I used this slide as well. Everything that we consider as software development is effectively a process of design. It's not a process of manufacturing. We are not manufacturing binaries or code repositories. We are writing and solving problems by creating designs, and the software that we use to solve those problems are design specifications, if you like. They're just very precise ones that can be executed. The manufacturing itself happens in the CPU. So this article by Jack Reeves back in 1992, that's just 30 years ago, talks about this in a lot more detail. Coding is design. Testing and debugging is a process of design. It's iterating on the design by identifying issues with that design. And then this comment strip also does a nice job of highlighting this. If you think about what software is, it's just a very, very detailed specification for what you expect to happen at the point of execution. And it takes a human to understand and create that. Obviously, we're starting to see some interesting edge cases with things like Copilot. I think there will be an interesting sort of next phase of sort of post-human or transhuman evolution of technology. If you're sort of optimistic about AI, maybe that's going to be the case. But for the foreseeable future, development and coding and all of that kind of stuff is still going to be fundamentally a human problem, because we are the ones with that creativity and that critical thinking. And so what this basically implies for software development is that it's continuous, iterative, and revisionist design. Creating something in code, like I said before, is not a manufacturing process where you turn Jira stories into lines of code. It is a process of learning how to solve a problem. And this is inherent in software. It's not a sort of a nice to have or something like that. It's just the reality of software development. It's not like building a bridge. We don't have physical limitations in the same way that you do in the properties of metal or concrete and things like that. If you've got continuous, iterative, and revisionist design, that means you need continuous, iterative, and revisionist threat modeling. So threat modeling is a process of continuous design and review of that design. This is a very sort of classic truism from product management. Software development, writing code is expensive. And typically from a product management point of view, if you are trying to validate an idea, probably the worst thing you could do is go and spend 6 months building that idea, go and building code to go and implement that idea, and then put it in front of a customer, because there's a very good chance that what you thought was going to be a good idea probably doesn't actually give the customer the value they need. So coding is expensive. You want to try and validate from a product management your idea as cheaply as possible, come up with a design, create prototypes, put these prototypes in front of your customers. And the same thing kind of applies to threat modeling. Threat modeling in initial design still makes sense before a single line of code is written. So it's the earlier you can start to threat model before lines of code have been written, whilst you're still thinking about it. Again, even this doesn't have to be a 3-month process. This could still be within the 3 days of that sort of design sprint. If you're starting to think about threat modeling within those 3 days, you're going to be setting yourself up for a lot more success than if you wait until you're writing code to do the threat modeling. And this allows you to test the security. So again, from a product management point of view, if you're building some new software, you're going to be looking at in terms of the value to the customer, the technical feasibility, the business viability, and sort of the usability. Well, we can also look at it in terms of the security feasibility or the privacy feasibility of your solution. Does this idea deliver value to the customer? Let's go and talk to the customer. Does this idea introduce us to unnecessary risk or what's the word I'm looking for? A sort of an unacceptable amount of risk? Well, that's where threat modeling can help, and that's where threat modeling can help provide some guidance, and it can help highlight some of the assumptions you're making about the design from a security perspective. So as a kind of corollary, threat modeling can only be fully automated when software development itself is fully automated. And I think realistically, we're going to be a long way away from that unless you're particularly optimistic about artificial intelligence. So as long as people are writing software, people need to be involved in threat modeling. Now, I'm talking about, this is supposed to be talking about threat modeling and threat modeling operations and the evolution of threat modeling. So I'm going to introduce a term here, being somewhat facetious, but I think it's actually quite a useful term. I'm going to refer to the term full stack threat modeling. And what I mean with full stack threat modeling is the holistic view of threat modeling across in this case, the Wardley map, right? So on the bottom right, we have cloud infrastructure and we have configuration management templates and all that kind of stuff, and things as code. That is ripe for automation from a threat modeling point of view as well. Where you are automating your technology, you should be automating your threat modeling. We should be leveraging those CloudFormation templates and Terraform in order to build out our threat models automatically. But that's only really going to be from the perspective of the cloud infrastructure or the configuration. We should be integrating threat modeling into the CI/CD pipelines and into the testing infrastructure, because that's where key parts of the software development practice is happening. That's where threat modeling should also be taking place. And then finally, at that top left, where you still have the key reliance on human expertise, threat modeling there should be design centric. So that should be getting humans to think critically with support from tooling and with support from automation, but still having them think critically about the implications and the assumptions that they're making from a security perspective at a higher level of abstraction, at the business logic, at the unique context of your organization, of your team, or of your application or product. That is something that realistically only humans can do. And where you get a sort of a better understanding, where you are able to leverage common knowledge, that's awesome. What that means is that just frees you up to evolve your top left even further. So there will be a continuous process of things evolving to the right, dropping down in terms of visibility as new practices and new approaches and new more sort of human and design centric activities take place on top of this built common knowledge. So we need to evolve how we think about and manage and integrate threat modeling at scale and velocity, because that's what happened with DevOps. DevOps evolved how we integrate and run and manage infrastructure and applications at scale and velocity. So what we need is something like threat model operations or TMOps or something like that. I stole that from if you look at what's happened more with machine learning space, a long time ago, machine learning was locked away in some sort of university lab somewhere. These days we've got commoditized services like in AWS and GCP and things like that. There's even a book out there called ML Ops. So it is the operationalization of managing your models in the artificial intelligence and machine learning space. So again, hypothesis, we're going to see something happen like this for threat modeling as well. We're going to end up with a threat modeling operations, a TMOps, or this is going to be a subset of DevSecOps, but threat modeling itself will be subject to the same forces and the same mechanisms and the same expectations that all the other star ops stuff is at. So if we kind of look at what happens from a development activity point of view, we can see what might happen from a threat modeling point of view and what that could look like as an implementation. So in that research, design, and prototyping stage, you've got high-level threat modeling to identify key assumptions and requirements early on. That's that human-centric stuff. So diagram your early high-level designs and feed those controls and those requirements and those assumptions back into your development process. That's where you should be looking at it and either going back to Jira or whatever you use to capture these requirements as issues, or maybe as acceptance criteria on your epics or whatever other design artifacts you're using. When it comes to the application or software development, again, design-centric threat modeling should be focused on the business logic and the unique context. So this, what is specific and special to your organization or to your problem domain, that's where you should be drawing things like functional components and data flows that describe the specific relationships of the sort of the high level concepts that you're dealing with. And again, the requirements and the assumptions that come out of that in terms of controls or non-functional requirements, feed those back into your development process through tests or Jira stories or acceptance criteria, etc. Testing, obviously important stage in development activity. You can test your threat models. So that's a key thing. Test your threat models both in terms of the coverage. So if you've got testing for unit tests or integration tests on your application and you block the build because the tests are failing, then you can also block the build if your threat models have too many open, unmitigated countermeasures, or unmitigated threats, sorry. But you can also, if you're leveraging some sort of a policy engine to generate these threat models, you should be building tests and looking for consistency and repeatability of the threat model policy engine over time and between environments. So at this point, threat modeling starts to feel very similar to the same expectations and controls as you would expect of the application code itself. So if I've got a threat model, we'll talk about this in a bit more detail, but if I've got a threat model that if I put a WAF in front of a load balancer, mitigated the SQL injection threat today, I would expect that to be the case tomorrow. And I wouldn't expect some sort of breakage in my policy engine to suddenly result in not having mitigated that threat, and or even worse, something that should not have been mitigated was mitigated by accident as a false positive. Infrastructure code and configuration management, all that kind of stuff, again, really focus on things like automated threat modeling of these artifacts, because the whole process has been automated to that point. Leverage that automation and build the threat modeling process around that automation. So use APIs or whatever to automatically build threat models from those commoditized components. CI/CD, again, we talked about that a little bit earlier. Soft and hard gates in deployment based on unmitigated threats. You can implement those kind of controls. And from a monitoring and maintenance perspective, once you've built and deployed your application, you typically monitor it for things. Well, there are things we want to be looking at from a threat modeling point of view. We want to measure your adoption of threat modeling. So how many of your applications have been threat modeled? What kind of return on investment are you seeing from threat modeling? Are you seeing a measurable reduction in risk as a result of threat modeling? And this is where it's useful to integrate it with other security and technology tools like SIEMs and SOARs, because you may want to create the feedback loops between threat modeling, the stuff that you're threat modeling, the infrastructure and the application, plus what's going on elsewhere in your environment, your vulnerability management and all that kind of stuff. So how you manage your threat models and how you manage your threat modeling should probably look like how you manage your other configuration and code. Treat threat modeling and threat model operations in the same way as you do development and DevOps. On this slide, what I've done is I've taken a classic sort of DevOps figure of 8 from Wikipedia, and I've overlaid that table of threat modeling activities associated with the different stages of the DevOps sort of infinity flow thing. So again, from a planning point of view, we've got design-centric threat modeling, and we're identifying security assumptions and non-functional requirements. When you're creating code, when you're doing that development process, this is where you should be thinking about threat modeling as code as well, threat modeling in the IDE. If you're creating artifacts like infrastructure as code, that should be threat modeled and ideally automatically. And this is again where we're talking about things like issue tracker integration. So feeding back the outcomes of threat modeling into the development cycle at the point of creation. Don't wait until you've gone all the way through this figure of 8 before you start feeding back from your threat model. It should be, there are iterations throughout this figure of 8. Verification, again, mitigations, testing, policy engine verification. Package and release. Interesting. It'd be interesting to see if anyone has particularly strong opinions here. From a threat modeling point of view, there's probably not a huge amount happening, but what would be quite interesting is how the development and deployment of an application or whatever, how the threat modeling of that ties to things like asset management and workflow integration. So should you be releasing that package if your threat model has not gone through a security review, for example, if your threat model is not being reviewed by security? Whether you do that or not would depend on your organization. A lot of large banks would probably prefer to do that, where other organizations may want to do that kind of review, maybe automatically or maybe retroactively. But that is a kind of a place where you can integrate at more of a workflow level. And then asset management as well. If you're releasing a updated version of software, and that software or that service is being used in other applications within your organization, within other services, that's something you could probably want to be looking for from a threat modeling point of view, like, are you designing in the use of outdated architectures or outdated services in other threat models? So by feeding back into your asset management at the point of release of a piece of software, you can then feed that back into your threat modeling to ensure that you are applying the latest and best practices and using the latest and best assets that are available within your organization. Configure, I'm going to interpret this as we've released a chunk of code, but at this point we're really configuring it and making it live. And that's a really good place to be integrating with things like application security, vulnerability management, and the cloud service providers. What you don't want to do is try and duplicate the entire purpose of something like a CSM, cloud security management, sorry, not cloud providers, the cloud security management. You don't necessarily, there are tons of tools out there, and it's a pretty mature market these days for looking at the nitty-gritty details of how stuff is configured live in a cloud environment. So you don't necessarily want to try and duplicate all of that in your threat modeling process, but what you want to do is threat model at the higher level of abstraction, but verify at that lower level, using integrations with AppSec, using integrations with vulnerability, and using integrations with cloud security management. And again, we're creating feedback loops back all the way from what's implemented in the running environments back into the threat modeling at that design and high level of abstraction. And then finally, monitor, as we said, we've got analytics, monitoring and return on investment, seamless or integration, and also risk management. So, making sure that we are comfortable with the overall level of risk that we're accepting within a business unit or within a line of business or whatever, and then actively managing that and prioritizing perhaps where you should be threat modeling, where should you be focusing on threat modeling, where do we need to invest more resources, where do we get the biggest bang for our buck in terms of the controls, which are our controls that are reducing the risk the most, but also cost the least, for example. So there's a lot you can do once you've operationalized threat modeling, once you have access to data, once you have metrics and measurements associated with threat modeling and that risk reduction, then you can start making data-informed decisions throughout the development process and at the sort of the more of the organizational level as well. So to make this kind of aspirational view of threat modeling in DevSecOps a reality, we need to build on the right foundations. So what we need is a standardized way to describe threat models that can be generated automatically, for example, from CloudFormation and Terraform, etc., or from design-centric tools, or even manually. It should be able to be integrated and used across the tech and the cyber stack. So, within CI/CD pipelines, within CSMs and vulnerability management. And it should be able to be shared and collaborated on within organizations, but ideally between organizations. So if I was a software vendor and I published my application or my service or my product, it'd be pretty awesome if I could publish with that a threat model that can be automatically ingested into different tools that allows me to immediately understand the risk and the requirements and responsibilities that I'm taking on for using that product or services. What are the things that I should be doing as a result of using this product or service, and having that published in a way that allows me to just sort of automatically ingest that and doesn't require me to sit there reading through 200-page documents. That would be a very highly operationalized way to do things. So finally, nearly towards the end of the talk, I'm now actually talking about the Open Threat Model Standard. So what we did at Iris Risk is decide, okay, there's a general problem here that we can see forming. What we don't want to do is try and solve this in a proprietary way that is just going to make the problem worse. What we want to try and do is try and solve this in a generalized way that is shareable, repeatable, and can be leveraged by the broader community. So we have proposed a threat model format or a threat model standard called the Open Threat Model. It's very early days yet, so we're really looking for contributions and input from the broader community. It's a YAML file or a JSON file. It's inspired by the Open API schema, so it should look very familiar if you're looking through it. It should read like any other kind of YAML specification. It's released under Creative Commons. So as I said, we're looking for contributions and feedback and thoughts from the broader community about what would you need if you wanted to operationalize your threat modeling and you wanted to represent a threat model using an interoperable and shareable standard. The specification covers all of the things you'd expect from a threat modeling specification. So it's got project metadata, things about the thing that you're threat modeling. Probably one of the more interesting things that relates back to that whole full stack threat model thing is the representations. So within a given full stack threat model, you may have different ways of looking at that application or service from the point of view of threat modeling. So you may be looking at it from a code perspective, let me threat model the application code, or you may be looking at it from an architecture or an infrastructure perspective, maybe even from a network perspective or a data perspective, from a privacy perspective, you may be looking at Jira stories. All of these kind of different representations of the same application can be threat modeled in different ways. So the OTM specification has the notion of different representations, so you can have different components associated with different representations within the same threat model. And we've got classic things like assets, the things that you care about within your threat models like PII and PCI data. Components, this is the building block of a threat model. These are the things that make up the representation, like a web server or a database or a process or something like that. Trust zones, of course, very important threat modeling, differing levels of security and trust between applications or components or even whole services. So classic one being you've got the internet trust zone, which is obviously scary and bad, and you've got your data tier, which is completely trusted and obviously locked down incredibly well. Maybe data flows, how the assets and the information move around between the components, of course, and then threats, the bad things that can go wrong, and mitigations, the good stuff that you probably should be doing to mitigate those threats. So all of this is contained within the specification. There's some other cool things in the specification as well. So objects can have arbitrary attributes, so you can use those where you need to do something with the specification that you can't do already. You can use these attributes to add additional metadata like custom identifiers, or maybe some sort of operational metadata that's specific to your organization. It has some basic risk properties, but we've had some feedback already that thinks we probably need to change that in the specification. Maybe something like a risk vector would be a much more generalized approach, or maybe making the specification a bit more modular, so you could have a fair risk module and sort of plug that into the right part of the specification where you need it. There are tags that allow you to classify and group components, X and Y positions for diagrammatic representations. You can nest trust zones components, and when using the actual YAML file itself, the number of required fields is really quite minimum. So you can quite easily write a YAML file that represents a threat model just by hand, which is really nice as a sort of a lightweight way of doing threat modeling as code. You can just start writing YAML files in your IDE to represent your threat models. So how does this then map back to TM Ops? Well, from a collaboration point of view, now organizations have a way of publishing a shareable and parsable threat model for their products and services, or even for educational purposes. Hey, here's an interesting use case from a threat model, from a threat modeling point of view. If you have this, then these are things you need to worry about. You can publish that as a YAML file that people can sort of ingest into their tools or into their infrastructure or into their SIEM or whatever. So those are things, there's another way of sharing and collaborating. Threat modeling as code. So obviously parsing and combining multiple representations into a single format is very powerful. Testing and verification. An interesting idea is taking something like Gherkin, the BDD and Cucumber-like language, to say, given a three-tier web application, when I put a WAF between the client and the load balancer, then I expect the SQL injection to be mitigated. So that's the kind of behavior you would expect from your threat model. You could generate an OTM, run that against some sort of policy engine, and then verify that that was the behavior from your policy engine. So you can, generating an intermediate file like OTM gives you that flexibility to be able to do that kind of stuff. And then finally, integrating into tech and cybersecurity stacks. Again, publishing an OTM file internally and then ingesting it into other repositories and other tools is obviously going to be sort of foundational for that kind of thing. We have a common way to describe it, therefore you only have to have one way to pass it. So I'm going to have a quick look for another minute or so, but I'm going to try and leave nearly 10 minutes for questions. We'll have a quick look at an OTM file over here. So as I said, we've got some project metadata, we've got description, some contact details, and some attributes. This could be enough, right? If you just dropped one of these into a repository and you scan across all of your repositories, you know to go and look for that threat model.yaml file. You suddenly have every single repository now has the foundations for a threat model in it. You may want to automate the generation of the rest of the threat model, or maybe you require people to write the threat model by hand or from the IDE or something like that. But at this stage, you can really scale out the detection of where threat models should exist just by dropping a YAML file into a Git repository. We've got a couple of different representations. One that's a diagram. We have some attributes like width and height, and one's a code. So we've got the repository, and then we've got assets. Again, we've got some sort of risk metadata that may or may not go away. We may not want to keep it as that. Components, of course, and they, as I said before, components can have and be tied to that particular representation. So we can have the same component relate to multiple representations. Those components can have threats associated with them as well as assets, and those threats can be mitigated as well. So we have mitigations associated with those threats associated with those components. So if I scroll down, we've got trust zones, and here we have our threats. So we almost have like a baked in threat and control library inside the specification. So I can reuse this threat throughout the threat model, or possibly just publish a OTM file with just all the list of threats that I want to see elsewhere. And there's our mitigations. All YAML, all relatively straightforward. We're using UUIDs here, but they don't have to be UUIDs. They could just be handwritten IDs or whatever identifying system you're using in your organization. The specification is opinionated on the structure, but less opinionated on the content where possible. So in summary, having a common format for describing threat models should hopefully allow us to commoditize the whole threat modeling process. Should enable that sort of TM ops. And that enables the automation and integration. And then that frees up people to do what they do best, which is to think critically and creatively. So if this is interesting, if it's controversial, or if you have any opinions strongly or otherwise, would love to hear from you. There's the Git repository for the specification, which, as I said, is released under Creative Commons. And feel free to reach out to me or use the OTM@your-risk email address if you want to share thoughts or ask questions. And that is it from me. Thank you very much.
Great stuff. Thanks, Fraser. Appreciate that.
No worries.
So we've got about 6 or 7 minutes. We've got a number of questions coming in, so we may need to be a bit pithy in our responses. Yeah, the first one I want to talk about is that threat modeling in general is a cultural shift or a mind shift, a mindset shift. For me, this makes it a whole lot easier. Is that what you see in practice?
Yeah, I think tooling and automation and the operationalization of threat modeling will go hand in hand with that cultural shift. So we do tend to over-focus on automation in the DevOps world, but you can't forget about the cultural aspect of DevOps, and the same thing will need to be true for threat modeling as well. But having instant and easy access to a tool can be a key driver for the right cultural changes as well. And it's not just boring people to death with slideshows that say this is what you should do in terms of a cultural shift. You can driving that through a tool is a very tangible way of helping to drive cultural shift. Yeah,
of course. Yeah. So a bit more specific, I think, around the open threat model. A few more specific questions, actually. Yeah. Is it meant to be technology agnostic? Certainly, it comes to like cloud infrastructure, AWS, Azure, all of the different names for the same things, essentially, don't they? But
yeah. So the way that works is it uses a type field that can be interpreted by whatever's using the OTM file. So it's completely agnostic to the source, and it's agnostic to the tooling that's leveraging it. And you can use these type fields to say, whatever you call that component, it's of a type EC2 server, EC2 instance. And therefore, tooling can leverage that type and say, well, if I see an EC2 instance, then in my tool, then I can interpret it as an AWS EC2 instance. So it is fairly flexible like that.
Okay. How might this differ from things like PYTM, Agile? I can always say that very well.
Yeah. So those are specific tools around describing. So in the talk I did last time, I did more of a comparison with other specifications out there, including Microsoft Threat Modeling, PYTM, of course. One thing is that this is trying to be agnostic to the tool itself. It's agnostic to the language. So PYTM requires you to write Python. This is just a YAML file, so it doesn't matter where your threat models are coming from, whether a Python or Rust or Ruby or CloudFormation, you have a common format in which to describe the threat model. So it's as agnostic as we can possibly be, but it's also agnostic to the tooling. So ThreatAgile has a very specific way that it thinks about threat models, and we try to take the good bits of all the tools and represent it in one common format that should hopefully work between tools eventually. Okay.
One question that's come in is around SaaS applications. Now we know that obviously with the shared responsibility model, changes. How might OTM work with SaaS applications?
That's a really interesting one, because what I think we're seeing a desperate lack of in the world at the moment is, if there's a vulnerability in a product or service that you've got deployed in a data center, you'll probably see a CVE for it. But a lot of SaaS applications can have vulnerabilities, get patched, and you'd never know. So a lot of that kind of stuff is quite hidden from us at the moment. So I'm a sort of bit of a pipe dream here, but one thing would be nice to see an API endpoint or a service orchestration layer publishing a threat model. So I could query an endpoint for a SaaS service, and it returns a blob of JSON that represents the threat model. If I can pass that automatically, I can then my application can respond in kind based on this sort of contract that I'm creating with this SaaS service. So, this doesn't have to be a file that's inside a Git repository. This kind of information could be returned by a SaaS service itself when, asking for, what's the security profile of this SaaS service I'm using? Here's a threat model as a JSON representation. That'd be quite cool. Don't know if we'd ever get there, but it'd be an interesting direction for things to go in.
Sure. Yeah, for sure. Talking about integrations, again, we are running out of time, but around generating these OTM files, how can we automate that, or is that just purely manual?
So no, so at Iris Risk, we are actively working on various parsers that generate OTM for, at the moment, CloudFormation, Terraform, and Visio. We're publishing that in a project called Start Left, which is also open source. It's on our GitHub organization, and that's a first attempt to take something like CloudFormation and automatically generate a threat model, rather than just like blindly taking the components or the resources within a CloudFormation and just drawing them as a diagram. What we're actually doing is mapping a CloudFormation template to what would be the architectural representation if you were to go and draw that by hand in a threat modeling tool. So we're basically interpreting cloud infrastructure as a threat model through this Start Left tool, and the same thing for Terraform for AWS and Visio as well. And that's again published as open source on our Git repository.
Okay, and you talked about diagrams there. Can you actually, you started with the Wardley maps to the threat model. Can you actually go and recreate or create diagrams back on the OTM format and actually visualize?
Yeah. So I decided not to include a visualization of it because I wanted to focus on the specification. But again, a tool like Iris Risk will take that OTM file or even a CloudFormation template directly and generate a visual representation of what it found in that OTM. So if you don't have any diagrammatic elements like the X and Y coordinates, then you can apply some sort of layout algorithm. Or if you do have it because it came from a Visio, you can just faithfully reproduce those X and Y coordinates in some other diagramming thing. And in fact, actually, I did a blog post where we took a GraphViz file and generated an OTM based on that GraphViz representation, you could very easily write a simple script that turned OTM back into a GraphViz representation or visualization of OTM. Yeah. So
Okay.
very good diagram. Yeah.
I think that's where we've got to call it a day there, Fraser. But thanks again for myself.
No problem.
Thanks
Thank you
again
very
from OWASP. Really enjoyable talk.